Students, we have to learn today about 4 points. First, conductor and insulator. Second, free and bound charges. Third, electrical capacitance of a capacitor. And fourth, capacitance of a isolated spherical capacitor. First, conductor and insulator. In the basis of their behavior, in an external electric field, materials are classified into two categories. First, conductor, and second, insulator. Okay? In conductor, the conductors are these substances which allow the large scale movement of electrons through them when in external electric field is applied on it. That is called conductor. Okay? And insulator are these substances which does not allow the movement of electrons or charge through them when an external field is applied on it. Okay, this is the insulator. And next, free and bound charges. What is free charge and what is bound charge? So in the universe, all the substances made of atoms, the consisting particle or the smallest particle is atom. Okay, this you can see this diagram. This is an atom is spherical. So in the center of the atom, positive charge is centralized. That is called nucleus. And around the nucleus, smaller concentric circles are there. These circles in the atoms are called orbits of the atom. And in these orbits, electrons are revolving. Okay? Now, these electrons revolving like that. Okay? This is the outermost orbit of this atom. And the distance from this nucleus, outermost orbit, is very large than that of this inner orbit. Okay? So, the attraction force of nucleus on this electron will be very weak than that of electrons revolving in this orbit. Okay, because the distance of this orbit is very small. Okay, so the electron revolving in outermost orbital, the electron is bounded by weak force, and this electron is revolving in the nearest orbit. That's why this electron will be bounded by strong force, attractive force. Okay, so this electron can be removed by increasing in temperature or by the thermal agitation. This electron may be detached from the atom. Okay, and this electron can move freely inside the conductor. And in the conductor, very huge amount of atoms are there. So in each atoms, in the outermost orbit, electrons are attached by a weak force. Then electrons can detach from this atom and can move freely inside the conductor. So these electrons which can move freely inside the conductor are called free electrons, because these electrons are having some charges. That's why these electrons also called charges. So these free electron also called free charges. Okay, and now in this orbit, this electron is bounded by strong attractive force with nucleus. This electron will not be able to detach from this atom. That's why this electron is called bound electron, or in this electron is having some charge. So this charge will be bound charges. Okay, that's all. Now next, electrical capacitance of a capacitor. Capacitance. What is capacitance? Okay, when external field or the external charge is applied on the conductor, then the conductor can store the charge or store the electric field. So the ability of conductor to store the electric charge is called their capacitance. Okay, so this is the capacitance. What is capacitance? The capacitance of a conductor is the ability to store the charge by the conductor. Okay, this is capacitance or electrical capacitance of a conductor. And next, capacitance of a isolated spherical capacitor. Okay, now this is a spherical conductor of radius capital R. Okay, and plus Q charge is given to this spherical conductor. Then this given charge is distributed uniformly on the surface of this spherical conductor. Okay, now the electric field lines or the force of lines will be perpendicular to the surface, perpendicular to that surface, along this direction, 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 like that. These are the electric lines of force on a spherical conductor. Okay, because the electric lines of force are perpendicular to the surface of the conductor. Okay, here it seems that these lines of forces start from this point. Okay, like that. Okay, so it appears that the charge is concentrated at the center of this sphere at point O, but actually charge is distributed over the surface. Okay, but it seems that the charge is so concentrated here. That's why these lines of forces starting from the center of the spherical conductor. Okay, now if we are assuming that this charge which is distributed over the surface, assuming that it is concentrated at that point O, okay, and here a point O, so the potential on the surface of the conductor, here this is point P, this point is P, so on the point P, potential will be V equal 1 upon 4 pi epsilon naught, and charge here, let this charge is capital Q, this charge is capital Q, and the distance of the point P from the center is equal to radius of the spherical conductor. So the radius is okay. This is the potential. We have to find the capacitance. So firstly, we have to know what is the capacitance and what is the formula of capacitance. Okay. So when given charge to the conductor is increases, the potential will increase. Okay, because Q is directly proportional to V. Q is directly proportional to V. That's why when V is Q means charge is increases, V will increase, and when charge is decreases, V will also decrease. That's why the Q is directly proportional to V. Okay, or we can say that Q directly proportional V. Okay, now, or Q equal CV. Here C is the proportionality constant, and here this proportionality constant is called capacitance of the conductor. So capacitance of the conductor will be Q upon V from this equation. Okay, now we have to find the SI unit. So what will be the SI unit? SI unit means Q charge. So the SI unit of charge, Coulomb. Okay, and V is potential, electric potential. So the SI unit of electric potential, what is your SI unit of electric potential? Volt. So here volt. So the SI unit of capacitance of the conductor will be Coulomb per volt. Coulomb per volt, and it is equal to Farad. Farad. So the SI unit of capacitance of a conductor is Farad, and the CGS unit will be state Farad. State Farad. This is the CGS unit, and this is SI unit. Okay, this is the capacitance of a capacitor. Now we have to find the dimensional formula. We can find the dimensional formula by this mathematical formula. So the dimensional of Q, dimensional of V. Okay, so Q, Coulomb. What is Coulomb? So the dimensional of Coulomb, 80. Firstly, C equal Q upon V. Q, but V equal W upon Q. Okay, so it will be Q square upon W. Now the dimensional of charge, AT and square. This is the work done. Work done, the dimension of work done, M L square T minus power 2. So it will be A square T square upon M L square T minus power 2, or M minus power 1 L minus power 2 T power 4 and A square. This will be the dimensional formula. Okay, now we have to find the capacitance of this spherical capacitor. For this, spherical capacitance of the conductor, capacitance or electrical capacitance of the conductor C equal Q upon V. This is the electrical capacitance. Why it is called electric capacitance? Because charge is stored in the conductor, and charge means charge is electric. So that's why this capacitance is called electrical capacitance. Now we have to find the electrical capacitance of this spherical capacitor. So here this is the formula, and now for finding the capacitance of the conductor, we have to firstly find V or potential of the conductor. Now let this is the point P on the surface of this spherical conductor. Now at this point, potential, what will be potential? Potential will be 1 upon 4 pi epsilon naught and Q upon R. What is Q? Q is given charge to the spherical conductor, and we assumed that the all charge is concentrated, all charge is concentrated at point O. That's why total charge is plus Q. Okay. Now this point O. At this point P, potential V will be Q upon R square, where R is the distance of this point from origin point, and this is equal to the radius of the spherical conductor. So this is the voltage or the potential or the electric potential on the surface of the spherical conductor. So the capacitance will C equal, on putting the value in equation C equal Q upon V, C will be equal Q upon value of V 1 upon 4 pi epsilon naught Q upon R. Q cancel to each other, and C will be equal 4 pi epsilon naught R. Okay, this is the formula. 4 is constant, pi is also constant, and epsilon naught is also constant. Okay, therefore C will be directly proportional R. What is R? R is the radius. Now if the radius of the spherical capacitor is increased, the capacitance is also increased. Okay, when the radius of the spherical capacitor or the spherical conductor, conductor not capacitor, we will study about capacitor later. If the radius of this spherical conductor is decreases, capacitance also decreases. Okay, this is the relation. These are the directly proportional to each other. That's why the graph between R and C will be like that. Here R and here C. Okay, this is the capacitance, and this is the graph between radius and capacitance of the spherical conductor. Okay.